Hey everyone, I'm Austin Anderson. Welcome to Chem 1314, experiment number 2. This is separation of the solid mixture. The first thing we need to do whenever it comes to separating a mixture of multiple solids is design a flow chart separating the solids out based on their solubility. In your lab manuals on page 2-3, you have these facts given to you. Imagine you have a mixture of 3 solids, aluminum, plasticizer, and a nitrocellulose. You're given that the aluminum powder is not soluble in acetone or benzene, the plasticizer is soluble in both acetone and benzene, the nitrocellulose is only soluble in acetone. So how can you separate those 3? Well, the first thing I would do is add acetone to it. Whenever you add acetone, the nitrocellulose is going to dissolve, the plasticizer is going to dissolve, and the aluminum is not going to dissolve. So that allows you to separate out the aluminum. It'll be solid, everything else will be in the liquid layer. You can then evaporate that acetone and now add benzene to it. Once you add benzene to it, the plasticizer is going to redissolve in the benzene, but the nitrocellulose is going to remain solid. So now you can separate those two, and you now have a separation of those 3 solids. Okay, so here's our flow chart. We add our acetone, the flow chart splits into a solid layer and a liquid layer. We have our aluminum here. We add our benzene to the liquid layer. We now have a solid liquid layer split again. We get a nitrocellulose here and plasticizer here. Okay, so that's a basic flow chart for us to work with today. All right. Now, the lab itself today is going to be a lot easier separation. We don't have to use any kind of organic solvents. What we're actually going to be doing is taking a mixture of salt, sand, and silt and separating out those 3 components based off of each component's solubility in water. Before we can separate out a mixture of the 3 components, we first have to figure out the solubilities of each of the components. Before we start testing the solubility, go ahead, throw my goggles on. That's unfortunate. All right, let's try this again. No strap breaking this time. Okay, so the first thing we need to do is figure out the different solubilities. So I'm going to take a small amount of the salt, sand, and silt and place them in my test tubes. All right, so in my 3 test tubes, I now have salt, sand, and silt. Okay, I need to add water to each test tube and observe the solubility. Give them all a good shake. This was the test tube that I had my salt in. Okay? So the salt has completely dissolved. So salt is soluble in water. Here's my sand test tube. I shake it up and the sand instantly settles back down to the bottom. So sand is insoluble. And silt, you can probably see it from here, but I'll give you a close-up. Silt suspends in water. Okay? It'll stay suspended for quite some time, and then it'll eventually settle out to the bottom. Alright, so we've got salt soluble, sand insoluble, and our silt suspends. So now what we need to do is devise a flow chart that allows us to separate a mixture of these 3. Okay? Well, we know that the salt dissolves completely. We know that the silt gets suspended and the sand settles out pretty quickly. If we start making our flow chart, we add water to it. In the solid side, that's going to be the one that settles out instantly. So that's going to be our sand. In the liquid suspension side, we have salt water and silt. If we take our liquid suspension and run it through a filter, we can filter off the silt and the salt water goes through the filter. So on the liquid and solid side after filtration, solid side is going to be the silt that we filtered off. The liquid side is going to be the salt, okay? So to get the salt by itself, we can evaporate the liquid in our beaker and we'll be left with salt alone. So I'm gonna go ahead, get my unknown, and start up my separation procedure. All right, so I've gone ahead and I've set everything up. I selected unknown number 1 for today. I weighed out 1.337 grams of my unknown and put it into this test tube. I weighed out my evaporating dish, my watch glass and filter paper, and my 50 milliliter beaker. Whenever we do our separation, we're going to add water to our unknown, mix it up to dissolve the salt and start separating out the silt. We're going to then carefully pour off the water layer into a separate test tube. We will go ahead and rinse that unknown like that 3 more times to make sure we get all of the salt and all of the silt out of the unknown. So after our rinsings, we should have just sand left in this test tube and salt and silt in this test tube. Then we can pour the salt and silt through the filter and separate off the silt. Okay, so the silt will be caught in the filter, the salt water will flow right on through into the beaker below. So at that point, we'll be able to take our sand, pour it out into this evaporating dish, get all the water out that we can, and then heat it up with a Bunsen burner to dry it out completely. So we'll just have the sand in our evaporating dish. We will take our beaker full of salt water after the filtration, and we will evaporate the water, leaving the salt behind. We will then take our watch glass, put our filter paper on it, and the filter paper should be full of silt by this point. We can take that, dry it out under a heat lamp, and we will have separated all 3 of our components. I'm going to go ahead, add water to my unknown mixture to begin separating the 3 components. So now, while the silt is still suspended, I can quickly pipette off the water layer, being careful to leave the sand behind at the very bottom of this. Go ahead and rinse this a couple more times at least. As you can see, there's still quite a bit of silt suspended in here. Alright, so this is what it looks like after my last rinsing. So now I have my sand separated here, and I have my salt and silt here. So now the next thing to do is separate off the silt from my salt. So to do that, I'm going to go ahead and pour this through my filter. While we let this filter, I can go ahead and start drying out my sand. Alright, so now I have pipetted off all of my excess water, and I will now dry this out with a Bunsen burner. So my sand is already dry, I've already killed the Bunsen burner. Now we're just waiting on the water to continue filtering. My salt water and silt are done filtering now, so I can go ahead, remove my filter. So to dry this filter now, I'm going to carefully open it up, set it down on my watch glass, and set everything underneath the heat lamp to dry. So meanwhile, while the silt is drying behind me, I'm going to take my salt water and dry it out over the Bunsen burner. All right, everyone. So everything is dried out now, and I have successfully separated all three components. I have my sand, my salt, and my silt. All right. I've already weighed everything. So the mass of my evaporating dish in component A is 28.178 grams. Filter paper, watch glass in component C, 31.974 grams. 50 ml beaker in component B is 27.955 grams. So now that everything is weighed out, the only thing that's left to do is find the percent composition of each compound in the mixture. Okay, so to do that, you take the mass of the component, so it's the component by itself, divided by the total mass of the unknown. So for my sand, I would take the mass of my sand divided by the mass of the unknown times 100%. That'll give me my percent composition of sand. Lastly, there's some post-lab questions that people tend to struggle a little bit with. These flowcharts, okay? How do you separate out a mixture of cholesterol, caffeine, and sugar given the solubility rules on question number 4? So given cholesterol is soluble in petroleum ether, caffeine is insoluble in ether, soluble in acetone, sugar is insoluble in both. Okay, so the first thing I would do is add petroleum ether to it to separate off the cholesterol. It's going to be the only one that's soluble, so it's going to go into the liquid side. Everything else is going to be insoluble, stay in solid. Then I would add my acetone to separate off the sugar from the caffeine. All right, and you use the same kind of rules to help you out with the second one, so number 5. With that completes experiment number 2. Thank you for listening. Have a good day.